Hello and welcome to another episode on Verilog by example series. In today's episode, we're going to be talking about use of struct to organize your logic elements or port lists and calls to functions, etc., so that you can encapsulate um, various data elements so that you can refer to them by name and so on. So let's look at how to use structs and what structs are. So structs are basically a structure that is defined in System Verilog that can encapsulate different data types. It can reference as a whole, the whole set can be referenced and copied and moved and passed through ports and through functions as arguments, etc. Or you can refer to them by name. So you can, for example, if str was your struct, you could refer to individual elements like str.f1, str.f2, and so on. Just like C, you can refer to the individual elements of a struct. Now, it can contain elements of different types. So they're like, unlike an array, they don't have to be all of the same type. They could be, one could be logic 16 down to 0, 15 down to 0. Another one could be an int, and so on and so forth, right? There's no restriction on that they should all be exactly the same type, same width, and so on. Now, there's also structs that are packed versus unpacked. And if you pack them, as you see here, when you pack the struct, the elements are essentially contiguous in memory. So if this was, let's say, 15 down to 0, and this was 15 down to 0, and this was 15 down to 0, then they would, by definition, be together. So you could basically refer to bit 16, and it would be here, and bit 17 would be here, right? So that is how the packed structs work. Now, if you do unpacked structs are basically you cannot say that the bit plus one would be F2. These are essentially three different locations in memory. The pointers for these would not be contiguous locations. So you cannot refer to them by the fact that they are contiguous blocks of memory and they are unpacked. So with that introduction, I guess I want to take an example and here I have my code. And so I'm going to pull up the this file called str.sv. And inside this, I define, first of all, I define these enums so that I can then pack them inside this. And I can show you essentially how this works. So the first enum is opcode. And this opcode, let's say we're trying to launch these Falcon rockets. And so the launch codes have 16-bit, opcode as to what we are going to do next. And then the second one is target. And target enum basically has various kinds of rockets that you can launch, Falcon 1 or Falcon 9, and so on. And then thirdly is this whole opcode struct, which is what instructions are we sending to our uh, launcher from the command center. So this contains an opcode, this contains a target, and it contains two timestamps here. Maybe you need a more fine-grained timestamp, so there are two timestamps here. Now, in our module, as you can see, we are not defining logic, 15 down to 0 and so on. We're just passing this as an output. So when this runs, this just sends this opcode struct t data as an output straight from this module. And we can also define logic elements inside the module, this command struct. And so it can basically be passed out as data eventually. And so we define a task, and this task also, look at this, task also takes as an input this opcode struct as an argument or parameter. Now inside this, we can run a case statement. A case statement can also use the C and refer to individual fields like c.opcode, and it can work on that. C.target, it can work on that and print all the required stuff. This is just a display command. It's just printing. So it's a task because there's really no outputs. Now in the initial statement, what we do is that we generate or we try to generate this command two different ways. And the first way is essentially we're going to assign individual fields, right? And the second way, and maybe if you're not seeing this, let me just make this a little bit better so you can see everything. So here you can see the first time I say command.opcode equals this, command.target equals this. and remember these were all defined above as a type def enums, and then timestamp equals this and this, and then I display it, right? And so this is method number one, where I'm referring to individual fields of the struct by name. The second method is because it was a packed, right? If you look at this, it was a packed struct. So I can just assign a whole bunch of bits to it as a contiguous set of bits. And when I try to display it, you'll see that it's parsed correctly into, like, this is init sequence, this is Falcon 9, and these are two timestamp variables, right? So this is what we're going to demo. So with that, let's just try to compile it. So there is your Icarus Verilog command to compile it. I'm using 2012 System Verilog Standard. And then when I compile it, it compiles without warnings. And when I run it, you can see that the first section thinks that it was a prepare Falcon 1 and these were timestamps. The second was init Falcon 9 and these were timestamps, right? So if we look at str again, the first one was prepare Falcon 1 and some timestamps, and the second one was init Falcon 9 and some timestamps. So the you can see that I've used structs that simplified instead of trying to refer to the exact location within the vector and saying, oh, it's at bit 39 down to you know 29 or something. That becomes very cumbersome to keep changing in your code. Instead, you can just use a struct and say, these are my set of bits, here's the various fields within it, and you can just refer to them by name. You can say, command.opcode. I'm changing command.opcode. I'm not saying I'm changing command, bit 63 down to 48 or whatever. Um, I'm just able to refer to them by name, which is very, very handy when you're trying to deal with code or even review somebody else's code. It's so much easier to understand somebody else's code when it's written in terms of struct. Now, structs are um, something that are now common in RTL, and should be able to compile them, should be able to synthesize them, and so on. And they make code very legible. So go ahead and try it in your next project, and let me know if you have further questions and if I can answer some of them for you. So hopefully you enjoyed this video, and if you liked it, give me a thumbs up, subscribe to my channel if you like this sort of content and want to come back to it. Um, and I will see you in another video. Until then, take care and bye bye.